Dear students, we are studying about those developments which uh, took us to the Bohr's model of atom. Till Rutherford's you have studied. So now we will study that what improvements were done in the Rutherford's atomic model. So two new concepts played a major role, and these two new concepts were wave nature of electromagnetic radiation and particle nature of electromagnetic radiations. Students, in Bohr's model of atom, these two things, that is the dual character of electromagnetic radiation, wave nature and particle nature, these two dual character played major role. And after that, the atomic spectra was drawn and experimental results of that played major role, and this is how Bohr's model of atom was given. Students, wave nature of electromagnetic radiation for the first time was given by Maxwell in 1870, and as per this electromagnetic wave theory, when electrically charged particle moves under acceleration, alternating electrical and magnetic field are generated. Students, I repeat, as per Maxwell's electromagnetic theory, when electrically charged particle moves under acceleration, alternating electrical and magnetic fields are generated, and these are transmitted in form of waves, and we call them electromagnetic waves or electromagnetic radiations. Students, these waves originate in the form of up and down movements. The point of maximum upward displacement is called crest, while the point of maximum downward displacement is called trough. Okay, so you can see this diagram. It is given here in NCERT book. X, Y axis is shown, and then these direction of propagation of waves are shown, students. That is wave motion actually. Now I am telling you some characteristics of these waves. They are very well expressed in terms of their wavelength, frequency, velocity and amplitude. Okay, so what is wavelength, students? Please listen to it properly, because you should make your own notes on this topic. First, I am going to discuss wavelength given by symbol lambda. It is the distance between two adjacent crests or two adjacent troughs is called wavelength. It has units of length. So different kinds of waves are of much smaller wavelengths. So we use smaller units of length to describe them, like angstrom. Students, 1 angstrom equals to 10 raised to power minus 8 centimeter or 10 raised to power minus 10 meter. Now second term I am coming to discuss, second characteristic of wave is frequency. It is given by it is given by a symbol nu. It is something like V, it looks like V. It is defined as the number of waves that pass through a given point in 1 second. Its units are cycles per second or simply reciprocal of second, that is second inverse. The SI unit of frequency is hertz, capital H and Z. This is after the name of scientist Heinrich Hertz. So 1 hertz equals to 1 cycle per second. A cycle is said to be completed, students, when a wave consisting of crest and trough passes through a point. Coming to wave number, students, coming to wave number, it is defined as the number of waves per unit length. Its unit is reciprocal of wavelength, that is meter inverse. However, it is commonly used in centimeter inverse, which is not SI unit but still centimeter inverse. Centimeter inverse is taken.